Hello everyone. Today's lecture we are going to discuss the different represented representation of a complex number. Right. What is the first form which we represent a complex number? First form is Cartesian form. Study representation representation of complex number. First form in which we can represent a complex number is Cartesian form. Cartesian form. This is the most popular, widely used method. Suppose any complex number z is there. This complex number z I'll represent as x plus iota y. What is x here? X is the x coordinate or the real part of the complex. What is y? Y is the imaginary part, or we can say the y coordinate or the imaginary coordinates of the complex. Now, here x and y belongs to real number, and in this case, if we'll find the modulus of z will be under root of x square plus y square, and argument of z argument of z will be tan inverse of y upon. Got it? Now next, when we will use this form to represent a complex number, we'll use this form to represent a complex number when when I'll be asked regarding the geometrical application or locus based question. We'll use this form. You can write used for locus problems or geometrical problems. Geometrical. These are the two places when we'll use this form. Got it? If I'll try to represent this complex number z, complex plane, I'll get this as this I have drawn y axis, one is x axis, and I can say if I'll plot this point x comma y somewhere here, I'll get the complex number z. This is my axis or real axis. This one is my y axis or imaginary axis. Right. So the representation of this complex number will be like this. This distance will be my y distance. This distance will be my x coordinate. Got it? Horizontal distance. The coordinate of this point z will become x comma y, where x represents the real part, the y represents the. Got it? Is trigonometric representation. Next form of representation is trigonometric trigonometric representation, or this only is known as polar or polar form. Now, how we'll use this form? In the earlier form, we represented our complex number z as x plus iota y. In this form, I will represent the complex number as r cos theta plus iota, r times cos theta plus iota sin. This is also known as r cis theta, cis theta. Got it? Where c stands for cos, plus iota, I stands for iota, s for. Got it? Now here, what is r? R is nothing but the modulus of this complex number, which will be the root of x square plus y square. What is the theta? This theta is nothing but amplitude of this complex number z. And as we know that the amplitude of complex number is always from minus 180 degree, open bracket, minus pi to plus 180 degree means. Got it? theta will always be in this range. Got it? R, R what I said, R is the modulus of this complex number. Modulus told in the previous videos also that modulus can't be, R can't be negative. Theta should be in either in second quadrant or in theta should be from minus 180 degree to plus 180, plus 180 open, plus 180, right? So now next, I'll try, or if I want to represent this, the complex plane, I'll draw my y-axis or imaginary axis. Next, draw x-axis, axis or real axis, real axis. Now next, this complex number I represented with the help of this r and this theta. This r is nothing but the distance of this complex number from origin. Complex number distance from origin. This is my r. Got it? And what is this theta? Theta is amplitude. Amplitude is measured from positive direction of x-axis in anti-clockwise direction. This one is my, got it? This distance is my y coordinate or is equals to imaginary axis. Yes, or this will be equal to r sine theta, and this distance will be equal to, from here to here, this distance will be equal to r cos theta. Got it? Complex number, if I'll assume it as x, y, my x is r cos theta, y is r, got it? Find out. Now we'll solve one question. We'll try to learn how to represent any complex number in r theta form or polar form or trigonometric form. Got it? So here we'll take one question. Suppose question is convert z is equals to 1 plus cos pi by 5 plus iota sine 6 pi by, we have to convert this complex number z in r cis theta form or polar form. Got it? So first of all, this angle theta, see, this is my real part and this one is my imaginary. Got it? So I'll try to combine them. I'll try to write them in the form of cos theta plus iota sine theta. Got it? So here, what is 1 plus cos theta formula? 1 plus cos theta, we'll apply this formula. 1 plus cos theta is equals to 2 cos square theta by 2, right? Sin theta can write as 2 sin theta by 2 cos theta by 2. Got it? Here we'll get z is 2 cos square theta by 2 3 pi by 5 plus 2 iota sin 3 pi by 5 and cos 3 pi by 5 by using these two formulas. Right? Now, what I can take common? I can take 2 multiplied by cos 3 by 5, 3 pi by 5 common, right? I'll take that common. Here I'll get z is equals to 2 cos 3 pi by 5 bracket, I'll get cos 3 pi by 5 plus iota sin 3 pi by, got it? Now it seems to be converted, right? Seems that this is our final answer. This is the value of r. Hence we have to convert in the form of like this, right? R cos theta plus iota sin theta. Here look at 3 pi by 5, right? So pi by 5 is 36 degree, right? So we can say that 3 pi by 5, 3 pi by 5 will be equal to 3 into 36 degree. So it will be 108 degrees. So 108 degrees means it lies in second quadrant. Lies in second. The cos of second quadrant is negative. We have seen that what is r? R is nothing but modulus of z. R can't be this can't be negative. So we have to make it a positive. Got it? What we'll do now, we'll apply a reduction here, right? Reduction here. What we are going to do here is write this z as 2 cos, and this 3 pi by 5 I'm going to write as pi minus 2 pi by 5, pi minus theta, right? This I'll write as pi minus 2 pi by, we also same, cos pi minus 2 pi by 5 plus iota sine pi minus 2 pi by, got it? So what is cos pi minus theta? Cos pi minus theta is minus cos theta, right? So here I'll get z is equals to minus 2 cos 2 pi by 5 cos minus cos 2 pi by 5, and here I'll get pi minus theta. Sin pi minus theta is sin theta. So here I'll write iota sin theta is 2 pi by, got it? Now next I'll send this minus inside. Here I'll get z is equals to 2 cos 2 pi by 5. When I'll multiply this minus inside, I'll get here plus cos 2 pi by 5 minus iota sine 2 pi by 5. Got it? Now next, now look here. Now this became positive, right? Our r became positive. Now here I want cos theta plus iota sine theta, right? So this minus also I'll send inside of sine. This I can write as z is equals to 2 cos 2 pi upon 5 cos 2 pi by 5 plus iota times sine minus 2 pi by, any doubt in this? Now if we'll see this r cis theta form, here sin theta and cos theta should be same. We know that this cos theta we can write as cos minus theta, also cos minus theta and cos theta are same. Here we'll write z is equals to 2 cos 2 pi by 5, and here I'll get cos minus 2 pi by 5 plus iota sine minus 2 pi by, got it? Now it is completed. So it is completely converted into r is theta form. Tell me what is the value of r? The value of r here is 2 cos 2 pi by 5. Here this theta is in 2 pi by 5 is in first quadrant. So 2 cos theta will be positive. This is positive. Next, what is our theta? What is theta? Or we'll say what is our amplitude? Our amplitude of z will be equal to minus 2 pi by 5. Amplitude of z can be negative, right? Amplitude of z can be from minus 180 degree to plus 180. So this is in that range. Got our answer. We can write in this form. Or we can write here in r cis theta form, means r is 2 cos 2 pi by 5 cis, the right cis theta. Theta is minus 2 pi by, like this also we can write. Understood? Now next is exponential form. It's also one of the most important forms, known as exponential form. Now next, right? Third way of representing a complex number is exponential form. Exponential, or this is also known as Euler's form. Euler's. Now next, first we have seen z can be represented as x plus iota y in Cartesian form. Got it? In first Cartesian form, and z can be represented as r cos theta plus iota sin theta. This only is known as r. This theta form is polar form or trigonometric form. Got it? This was polar form, was Cartesian form. Now we'll learn how to represent in Euler's form. In Euler's form, we can represent the complex number z is equals to r cos theta plus iota sin theta as e to the power r e to the power I theta. Or basically what we are doing, we are writing this cos theta plus iota sin theta as e to the power iota theta, as e to the power iota theta in this form. Got it? Basically we are doing this, generally we are writing cos theta plus iota sin theta as e to the power iota theta. Now tell me, what is this r form? This r is nothing but modulus of z. R should be positive as modulus of z is positive. Got it? Now next, what is theta? Theta is nothing but my amplitude of complex number. Now how we can write cos theta plus iota sin theta as to the power I theta? Right. So we'll try to prove this. Try to do the proof of this cos theta plus iota sin theta is equal to e to the power I theta in two different ways. Got it? So the proof of cos theta plus iota sin theta is equals to e to the power iota theta. We'll do the proof by two different methods. First method is we'll do with the help of expansion, the Taylor series we studied in limits, right? So tell me, what is the expansion of cos theta? What is the expansion of cos theta? The expansion of cos theta is 1 minus all the even power terms will come. Even power terms. The expansion of cos theta and alternate plus minus sign. Got it? 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial and so on. Right? Now next, what is expansion of sine theta? All the odd powers term will come. Right? Odd power term means first I'll get theta, next minus theta cube by 3 factorial plus theta to the power 5 by 5 factorial. Got it? Now we'll put this to in the left hand side. Left hand side, what they give? In left hand side they give cos theta plus iota sin theta. When I will multiply iota here, I'll get iota theta minus iota into theta cube by 3 factorial plus iota into theta to the power 5 by 5 factorial and so on. Now we'll multiply at our left hand side. Sorry, we'll add both the equations. So what I'll get here, cos theta plus iota sin theta is equals to 1 plus iota theta, next minus theta square by 2 factorial minus iota theta cube by 3 factorial plus theta to the power 4 by 4 factorial plus iota theta to the power 5 by 5 factorial and so on. This is the expansion of cos theta plus iota sin theta. Now we'll expand e to the power iota theta. Now tell me, what is the expansion of e power x? E power x expansion we have seen is equals to 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial plus x power 4 upon 4 factorial plus x power 5 upon 5 factorial and so on till infinity. So now in place of x, if I'll keep iota theta, means we are calculating what is our right hand side. What is our right hand side? get the right hand side, get the expansion of e to the power iota theta. Here x I will keep as iota theta. I'll keep here iota theta. What I'll get expansion? Expansion I'll get e to the power iota theta is equals to 1 plus iota theta upon 1 factorial plus here in place of x square I'll keep iota theta, so I'll get iota square theta square by 2 factorial. Next here I'll get iota cube theta cube by 3 factorial plus iota to the power 4 theta to the power 4 by 4 factorial plus iota to the power 5 theta to the power 5 by 5 factorial. Now next again we'll simplify this one. So here I'll get e to the power iota theta is equals to 1 plus iota theta by 1 factorial. Now what is the value of iota square? Iota square value is minus 1. Got it? Here I'll get minus of theta square by factorial. What is the value of iota cube? Iota cube is minus iota. Here I'll get minus iota into theta cube by 3 factorial. Next, what is the what is the value of iota to the power 4? Iota to the power 4 is 1. Here I'll get iota theta to the power 4 by 4 factorial. Next, what is the iota to the power 5? Iota to the power 5 is equal to iota. So here I'll get iota theta to the power 5 by 5 factorial and so on. If you will observe carefully, my right hand side, this one, my right hand side, we got this, and in my left hand side, we got this. Both are equal. Both are equal. When we expanded our left hand side, when we expand our right hand, both we are getting exactly same expansion. Here we can say left hand side is equals to right hand side. Hence, both are same. This is our left hand side. This is our left hand. Got it? Now we can expand it by one more way. Sorry, we can prove it by one more way. We'll see method 2 of proving. Now we'll do the proof of cos theta plus iota sin theta equals to e to the power iota theta by third 2. To do the proof by third, in this method what we'll do, we'll start with left hand side. Let the left hand side be, what is left hand side? Left hand side is cos theta plus iota sin theta. This I'll assume as y. Got it? Now can you tell if theta is 0, what is the value of y? The value of y will be 1. We are going to use it, right? Now next, now find dy by d theta. Dy by d theta will be minus sin theta plus iota cos theta, right? Differentiation of cos theta is sin theta is plus. Got it? Now dy by d theta, in this expression take iota common. If I'll take iota common, right here sin theta upon iota plus cos theta, right? Now what is 1 by iota? 1 by iota is minus iota, right? So here what is minus 1 by iota? Minus 1 by iota will be equal to iota. So I'll get here iota. Here I'll get iota sin theta plus cos theta. Got it? So what is iota sin theta plus cos theta? Iota sin plus cos theta is nothing but my y. I can write as y. Here I'll get dy by d theta is equals to iota into y. Now next, now next, now we'll try to integrate this one by variable separable. Listen, here I'll write dy by, I can send this y to that side. Here I'll get dy by y is equals to iota times d theta. Now we'll integrate both sides. We'll get here 1 by y. Integration of 1 by y is ln y. and iota is a constant, so I'll keep iota out. Integration of d theta is theta, and one constant of integration c. Got it? Now, how to find this c value? We'll use this form. When theta is 0, y is 1. Keep theta as 0. If I'll keep theta as 0, this term I'll get 0. So y is 1. ln1 is also ln1 is also right. C value from here we'll keep back the value of c in the equation. So this equation will get in this equation will ln y is equals to iota theta, or from here y is equals to e to the power iota theta. Hence, proof. What was y? Y we proved is equals to e to the power iota theta, and y we have taken cos theta plus iota sin. Here we can write cos theta plus iota sin theta is equals to e to the power iota theta. We finally proved statement cos theta plus iota sin theta is equals to power iota theta. By two methods we did, right? First one by using the expansion of cos theta sin theta and e power x, and by the second method we did by using differential equation. Got it? Now we'll see one more interesting question. So now we'll see one more interesting question. Suppose in a question they gave, find the value of iota to the power iota, iota to the power iota. The options they gave, A option is e to the power minus pi, B option is e to the power minus pi by 2, C option is e to the power pi, and D option is e to the power pi by 2. Now, how will solve this one? Look at the question carefully. Question is very interesting, right? Why? Because here you can see I is an imaginary quantity, iota is imaginary quantity, right? Purely imaginary. To the power iota, imaginary to the power imaginary is giving something real. Because in options, none of the option is, all the options are e is real, pi is real. Power minus pi will be real. This is also real, this is also real, and same with option D is also real. Got it? So we'll try to solve. Question is based on Euler's form, right? The last form we studied. To the power iota, r e to the power iota. The complex number that we can express the form of r e to the power iota theta. First, we'll try to express this iota. Tell me iota what I can write. Iota I will try to write in the form of r e to the power iota theta. What is r? R is the magnitude of this complex number. What is the magnitude of iota? Iota magnitude is 1, right? So here r value will be 1. Here we'll get I but 1 into e to the power iota theta means what is the amplitude of I? Pi by 2, right? One I can write as cos pi by 2 plus iota sine pi by 2, right? Cos pi by 2 is 0, iota sine pi by 2 is, cos sine is 1, sine pi by 2 is. Now, iota I can write as 1 into e to the power iota pi by 2. Yes or no? Now next, I'll raise both sides with the power iota. Iota to the power iota I can write as nothing but the base iota I can write as e to the power iota pi by 2 to the power I. Got it? So iota I can multiply the power. Here I'll get iota square into pi by 2. Right? From here we will get e to the power minus pi by 2 because iota square is pi by 2. Got option number B as our correct option. Hope you enjoyed this lecture. We'll meet in next lecture.